So to start off with, we want to click on our lower body tube and we want to add our fins. I'm going to show you guys how to do the freeform fins because that is the hardest fin of them all. The other two fins are pretty simple and all you have to do is change the parameters. But this one, you actually need to do a little bit of drawing. So I'm going to click on freeform. You'll see it'll automatically make the fins for you. And you can see all these different settings. I'm going to go ahead and set mine to 4 fins. And we're actually going to ignore this value right here called fin count. Now what it does, you can actually play around with it if you want, is it tilts your fins. You can kind of see it because I'm on the side view right now, is it angles them. And the purpose of that is so that your rocket spins. And in some cases, that is a good thing. But if you're trying to go for height instead of style points, I would suggest not having a fin count and just making them as straight as possible. So I'm going to keep mine at 0. Next thing is our fin cross section. So to show you what I'm talking about, I'm actually going to go into 3D mode really quickly. 3D figure. And you can see it looks a little bit weird. Actually, I should go to 3D finished. Yep. So you can see I have a 3D model of the fin. And what I'm talking about with the section, right, the cross section, is actually what the edges of the fins look like. So like, say, this black edge right here. And if you change this, you can see that, I guess it doesn't show it in OpenRocket, but those edges will actually be rounded instead of sharp. And that does affect your aerodynamics quite a bit because it allows air to roll off or move past your fins a lot easier. Typically, we recommend rounded fins, not just square, because squared fins typically are not very good for aerodynamics. Now, if you really wanted to, you can use something called airfoil. And it's a special form of tape that is specifically made for the edge of your fins to allow air to roll by it. But you also have to round your fins first and then use airfoil. But typically, we just say to round it just because it's the easiest and least costly, because you don't have to use airfoil and it's pretty expensive in the aerospace field. And then last things last, just like your centering rings, if you plan on laser cutting your fins, you're going to want to change the thickness to the sheet of wood that you plan on using. So remember, the makerspace has either an 1/8 of an inch or a 1/4 inch. So if I were to plan on laser cutting with an 1/8 of an inch sheet of plywood, I would put 0.125 or an 1/8 of an inch right here. Next, let's look at the component material. This is going to be plywood once again, because it'll be 3D printed, or not 3D printed, it'll be laser cut from a plywood sheet. Then component finish, that's just the spray paint once again. And fillets. This is a very important component of your rocket. So let me see if I can try and show you. I don't know if it'll show up, it does not. But what fillets are is it's basically a bunch of epoxy that holds your fin to the body tube of your rocket. It's basically just a slope from the bottom of your fin to your body tube. And all it does is strengthen it and just make sure that it won't break upon impact on the ground. So typically we want to make sure that we have these fillet radiuses, or these fillets. And we typically have them around 0.3 inches. That's not the most accurate dimension because it will be a little bit different in real life, and it'll be a lot harder to get that exact dimension. But that is going to be as close as we can to a realistic dimension. For the most part, it doesn't affect aerodynamics very much, but it does affect weight. So I would suggest adding your fillets here. Then we want to select the fillet material. So what we use for fillets is epoxy. So OpenRocket itself doesn't have epoxy built in, but you can see I already added the material myself. So I'm going to go through the process of how to add your very own material so that you can have epoxy just like me. So I'm going to write down this number, 0.694, so I can remember that's the thickness of epoxy. And when you're entering in epoxy, to your open rocket, you can use this value as well. Then I'm going to go down here to custom. That's at the very bottom of the list. And then this will show up right here. You can name the material whatever you want. I'm going to name it epoxy, right? Because I'm trying to do epoxy. And this value right here, the material density is supposed to be 0.694. And you want to make sure that you're in ounces, inches cubed, so that it's the density of the item. And then you want to click on add material to database, so that if you open Rocket in the future in a different project, this item will be in every project now. So no matter what project you use, you can go here and then select epoxy. So since I already have mine added, you can go ahead and click OK on that box instead of cancel like I did. And you can just click on epoxy from right here, or it should auto-populate as well. All right. Now, that is it for your root fills. And you can see here that my stability has actually changed quite a bit. From negative 52, it actually went to positive 17.6%, which is actually pretty good. I'm going to go ahead and go back to my side view so I can see the side. And now we're going to change the look of our fins. To do that, we have to go over to the fin shape tab. Now this is the difference from this fin and all the other fins, because it has a way to shape it to your liking. So you can see here that this is in light mode. It is a little bit weird, but you can see that it has these little red tabs that you can click and drag and move to any position. And you can actually see it changing in real time as well. Now, one good rule of thumb to keep while you're editing these positions is to keep an eye on these boxes on the left-hand side. And you can actually change these values as well to make them more rounded values. Because when I click and drag, it makes it kind of a random value, like say 1.134. That's kind of a hard value to remember, and say when you're 3D modeling your fins so that you can go ahead and laser cut them, you want to make sure that these values are nice and easy so that you could just type it in really quickly. So I would double click on here and then change it to a number that I can remember. So like say 0.5, half an inch. That's just a simple, easy number that's easy to work with. And then one last rule of your fins is when you're making your fins, you actually don't want them to go past the bottom of your rocket. And the reasoning behind that is when your rocket drops to the ground, it will have the bottom of your rocket hit first. Now, the base of your rocket is actually a lot stronger than the base of your fins. Your fins will most likely snap if they hit first. So that's why we typically recommend to have them above the bottom of your rocket. So now I'm just going to change my fin to look a little bit different to my preferences. I'm actually going to purposefully make them lower my stability quite a bit. I would also keep an eye on your stability while you're making your fins and seeing if you can get around that 10.3 to 10.9%, as you see right here. I'm actually going to lower mine to around 8 because I want to show you guys a different method of changing your stability. So my fins look pretty wacky, but they will work if you want them to. And then the very last thing that you have to do for your fins is add something called a fin tab. So we're going to click on this tab right here that says fin tabs. And what fin tabs are little squares that go inside of your body tube. And their purpose is to hold your fins to your body tube. And you're going to have to cut slots in your body tube, just like this picture demonstrates. You can see that your lower body tube here has little slits for these boxes to go into, just so that you can epoxy it in. So to do your fin tabs, we're just going to go ahead and change the tab length, the tab height, and the tab position. So to start off with, I'm going to keep my tab position at 0 because there's no reason for me to really move it from the center of the rocket. or the center of your fins. But you can move it all the way to the left-hand side, or you can move it all the way to the right-hand side if you want to, but I'm just going to keep mine centered. Then for the tab height, you can see as I change this value, it actually shows me in real time what the tab height will be on the rocket itself. I would just pick something that's going to be touching your inner body tube, but that won't be going inside of your inner body tube. Because the only thing we want to be inside of is the outer body tube. We don't want to protrude into the inner body tube. So it looks like for that value, my value is 0.2 inches. So I'm going to keep it there. And then tab length, that just changes how long it is along your fin. So if I change that to the max value, you can see it spans the entire fin. But if I have it on the entire fin, you can see it interacts with my centering ring, which won't work. So I'm going to go ahead and click and drag this so it's a little bit smaller than my centering ring, so I have that space for it when I go to build the rocket. And after that, you're pretty much done with your fins. So you can go ahead and just hit OK, and you're good to go. The last couple of things, the last kind of a couple of touch-ups that I would like to add would be your bulkhead, your parachute, and your shock cord. So let's go ahead and start with the bulkhead. So you want to click on your tube coupler to add it, because in the rocket diagram you can see here that your bulkhead is actually going to be right inside of your coupler. So we're going to click on the tube coupler and click on bulkhead. Now you can just ignore all of this once again. And if you plan on 3D printing your bulkhead or laser cutting, I would recommend either a thickness of 1/8 of an inch or 1/4 inch. I think that's just a good rule of thumb to keep in mind if you plan on 3D printing or laser cutting. So since I plan on laser cutting this, I'm going to do 1/8 of an inch because all of my other parts that I'm laser cutting are also 1/8 of an inch. And you can see, oh, sorry, I changed the diameter instead of the thickness. There we go. And for the diameter, you can just click on this automatic button and then it'll change it for you. Last thing for your bulkhead is the material. Since I'm laser cutting, it's going to be plywood. And you just hit OK. And then we're going to go ahead and add our parachute and shock cord. Now this is actually a very important part of your rocket, so that you can make sure that it lands properly and doesn't break upon landing. So I'm going to go ahead and go to Apogee Components once again. And I'm going to go ahead and select the parachute from here. So I'm going to go to Shop, go to Building Supplies, and then I'm going to go to Parachutes. Now remember, this is just the website that I'm using for this video. You can use other websites like Mad Cow or Lock Precision. You don't have to use Apogee Components if you don't want to. And you want to look at the high power parachutes, not the mid power, not the low power. We're making a high power rocket, so we want a high power parachute. And you'll see all of these different chutes show up. I typically recommend to start off with a 24-inch parachute and then move up from there. Now you can see this 24-inch parachute is actually very, very expensive, but there are other ones that are actually pretty cheap. I'm actually going to go to a different website called Top Flight Recovery because they're pretty good at parachutes and they're actually a pretty good price as well. So you can see here that they have the PAR 24 24-inch parachute and it's only $12. And you can choose the color, like say if I want purple, if I want red, if I want, a different size. You can pick it all right here. So I'm going to go ahead and say I want the 24 and then I want red for whatever reason. So now that I have my parachute picked out, I'm actually going to go back to Apogee Component, or not Apogee, to Open Rocket. I'm going to click on the lower body tube because your parachute is going to be located in this area of your rocket. Then we're going to click on the parachute component and you'll see this list pop up again. Now we're actually going to use this component list because it'll populate all of the values for you based off of the parachute that you choose. So you want to look up Top Flight Recovery, or whatever manufacturer that you go with. And since I went with Top Flight Recovery, I'm going to look for the part number that I picked. Now you can see here that the part number is PAR24. And PAR24, funny enough, is just right here. So I'm just going to go ahead and double click on that. And you can see it automatically populates with all the different values. And the only thing you really have to do is move it. So you can move your parachute probably a little bit lower. Typically your parachute is going to be more central. And you want the packed diameter to be automatic so that it snaps to the inner diameter of your body tube. And you want to change the packed length to span pretty long, mainly because your parachute will be stuffed in there, but it will be still pretty long on your body tube. I would suggest around 4.5 to 5 inches, and make sure it's centered within your motor and your bulkhead. Then we're going to go ahead and add your shock cord next. All right, so to pick your shock cord, we're actually going to go back to Apogee Components again. And then we're going to go over to the shop, go over to Building Supplies. And they have a section for shock cords just right here. And we can click on that section. And we want to make sure that we're getting the right kind of shock cord. Now, we typically recommend the Kevlar cord 1500. Mainly because we want to make sure that it has that 1,500 pound test strength so that it will not break underneath the heavy loads that we need for our rocket. So to determine the length of your shock cord, you actually need to multiply the overall length of your rocket by 3. So in my case, I have 40 inches, and if I multiply 40 inches by 3, it'll be 120. So that means I need 120 inches of shock cord length. And the way Apogee does it, it's a little bit weird, but each value here, each one is equal to 10 inches. So I actually want 12, so I have 120 inches of length. So, next things next, we're actually going to go ahead and select this cord from our parts library and add it to our rocket. So we're going to click on shock cord right here. And you can see it populates shock cord length, has the elastic cord material, has the position, all of that stuff. So our overall length is going to be 120 inches for our shock cord. That's just a lot of length. But it is necessary to make sure that your rocket lands safely. Then we're going to go ahead and select the material. So let's look at Apogee Components, look at what the material is, and you can see here that the material is a Kevlar cord. So we're going to go ahead and see the Kevlar cord, and it's asking for some dimensions. So we're going to go back to Apogee, look for the dimensions that it mentions, and we have an outer diameter, and we have a weight. All right, so you can see here that our outer diameter is actually close to 1/8 of an inch. So we're going to go here, find a Kevlar cord, a Kevlar 12 strand that is close to 1/8 of an inch. And you can see right here that this is the closest one. So I'm just going to go ahead, click on that Kevlar strand right there, and that's the kind of shock cord material you want. Next, we're going to do the same thing that we did for the parachute. We're going to click on automatic, and we're going to change the length to the same length as your parachute. Apologies, I changed the position. Packed length, I'm going to change to 5 inches. And you can see, changes that packed length. So next things next, we're actually going to reorder the parachute and the shock cord just a little bit, where the shock cord is mainly going to be stuffed down at the bottom with a small strand going up to your bulkhead, and your parachute is actually going to be towards the top. So it should look something like this, distribution of weight-wise. Next things next, we're actually going to have something called an eye bolt right here for our shock cord to tie to. So we're going to add something called a mass component. So to go ahead and add that mass component, we're going to go ahead and click on this right here. And you'll see it populates as a little box and you can move it around. You're typically going to want it to be at the end of your bulkhead that you added earlier. So around right there. And eye bolts are usually around 20 grams. So we're just going to go ahead and type in 20. And that'll go ahead and be our eye bolt. And if you want, you can also go up here to component name and you can name it eye bolt. All right, so now that we have our eye bolt done, we can just hit OK. And we have one last thing we need to do. So you can see that my stability is 8.78 right now. It's actually not at the stability that I want. So to fix that, we can actually add some mass inside of our nose cone. So to do that, we're going to go ahead and add another mass component. And you can see it starts at the very tip of your nose cone. But to make it more realistic, you actually want it to be more inside of your nose cone. Like so. And then we're going to go ahead and change the mass until my stability gets to that range that I want, the 10.3 to 10.9%. So I'm going to change it to, say, let's go 100 grams. And you can see my stability shot up to 17%. For the most part, you shouldn't have to add all that much mass. And if you do, that's okay. I would say the max amount of mass that you can add is around 150 grams. So to do this, I'm going to go ahead and move down to 20 grams. And you can see my stability is actually 10.7%. I'm going to bump it up just a little bit to see if I can get that 10.9. 21, let's try 25. Nope, 25 is a little too high. 24, nope, 23. 23, that is my value. So that will be my mass component up at the top. Now, when we go to weigh all of these components in real life, once you have them all laser cut, 3D printed, all ready to go, we're actually probably going to have to change this mass up at the top, because we're going to go through, say your body tube arrives in the mail, and then we're going to measure the weight of your body tube, and say we go to override over here, override mass, and say our weight is actually around 50 grams instead of 46.8, like Open Rocket calculates. So if it's actually 50 grams, you'll see my stability actually went up a little bit higher. So what you'll have to do is go into your mass component and change that down so that it'll give you that 10.9%. But that's something to worry about more when we go to build your rocket. As of right now, we're just in the design phase. So that is pretty much it. If you want to put something in this body tube, you can. Typically, to make a functional rocket, there's nothing there, but just make sure you balance it out and get that good stability. And the last thing we want to actually look at is our flight simulations, and we want to look at our ground hit velocity. And you can see mine is actually pretty low right now. As I said before, we want to have ours around 20 to 26 feet per second. So I may actually change my parachute from a PAR-24 to, let me go to top flight. I'm going to change it from a 24-inch to an 18-inch. And you'll see my ground hit velocity is now 5.2 feet per second. We just want to make sure that this is within that 20 to 26 feet per second range. Because if it's too slow to hit the ground, then your rocket will just float away and then we'll never see it again, you know? And we want you to be certified. So let's make sure that we have a good ground hit velocity. All right, and that's pretty much it for the simulation video. How to start off with Open Rocket, how to build your own design. It doesn't have to look exactly like mine. Go ahead and have some fun with it. You can even add some fins up here. You can make them look all wonky. You can do all the stuff that you want, just as long as it flies. That's the important part. We just really want to look at that stability, and we really want to look at that ground hit velocity. Jeez, that shot up. All right. thank you guys for watching. I hope this video has been informational for you guys. And you can always ask me any questions that you have either in our Discord or you can email me. And yeah, thank you guys for watching.